So today we're going to be doing graphing between two curves. So it's chapter 7.1. So the first problem we're going to do is we're going to have two equations. The first one's going to be f of x, it's going to equal y squared, and g of y is going to equal 4y plus 5. And so we can go ahead, to make it easier to graph, just go ahead and make this in terms of y. So we're going to have y equals plus or minus the square root of x, and y equals x minus 5 all over 4. So then we're going to go ahead and sketch the graph, and we're going to have like a horizontal parabola and then just a linear function. So we're going to be finding the area right here. And then we're going to have and so since it's going to be top minus bottom, the top equation is the y squared. So it's going to be the integral, we're going to integrate 4y plus 5 minus y squared dy. And if you set these equal to each other, so you have y squared equals 4y plus 5. So you can just find out you're going to find negative 125 at your intersection points, and then for the x values it's going to be negative 1 and 5. And so for the y values, negative 1 and 5. And then so you're going to integrate from negative 1 to 5, 4y plus 5 minus y squared dy. And then do the antiderivative of that. It would be 2y squared plus 5y minus y cubed over 3. Pencil broke. From negative 1 to 5. And you can go ahead and plug in for 5, so you're going to have 50 plus 25 minus 125 over 3 minus 2 minus 5 plus 1/3, and that's going to all come out to 36. And so the next problem we're going to be working on is the same thing, but our equations are going to be x equals 2y squared minus 2 and x minus y squared equals 7. So the first thing we're going to go ahead and do is put the paper up a bit. First thing we're going to do is again put them in terms of y for easier graphing. So we're going to have y equals square root of x minus 2 all over 2, and y equals 7 minus x. Sorry, square root 7 minus x. And both of these are going to be plus or minus since you're going from a from a power to a radical. And then so we're going to go ahead and graph those equations. And it's going to be, one is going to start earlier but have a lesser slope, smaller slope. It was going to get overtaken by the other one. You're going to have this shape, and then it's going to be reflected over the axis just like that. So what I'm going to go ahead and do is find just 1/2 of the shape, since these graphs are symmetrical over the x-axis. And the first thing we're going to need to do though is have them equal to each other. 2y squared minus 2 equals 7 plus y squared. 2y squared equals 9 plus y squared. Y squared equals 9. Y equals 3. And then I'm going to go ahead and solve it in terms of do like a vertical reference rectangle, just because I find those a little bit easier, and it just adds another step to the problem for more practice. And what we're going to do there, so we have our y value, we need to find our x value for the intersection. So x equals 3 squared minus 2, x equals 18 minus 2, x equals 16. So our intersection point is 16, 3. And since we're going to have the same, we're going to have two intersection points that are going to overlap. And since they're symmetrical with the axis, you can just add a 16 and a negative 3. So we're going to be over the same place. Then, so since we're just doing half, actually we can forget about that. And do the integral from 0 to 3, 2y squared minus 2, minus 0 to 3 of 7 plus y squared, top minus bottom. That's going to get us 0 to 3 of y squared minus 9. And then you can simply plug in numbers, and you'll end up getting 0 minus 9. And it's going to equal, sorry, skip, you can't plug in numbers yet. I have to do the antiderivative. So y cubed over 3 minus 9y from 3 to 0. And then it's going to be 9 minus a negative, so plus 27 equals 18. And since that is only half the area, we're going to have to multiply it by 2. And so 18 times 2 equals 36, and that's our answer. And as it